Well, hello everyone. Today we're going to start chapter 7. We're going to deal with radicals and in particular how to simplify them. So let me start off with what is a radical. A radical is essentially things like square roots, which is written like that, cube roots, written like that, and you could actually keep going. You could have fourth roots, things like that. So a square root is an example of a radical. And the square root of 25 is a number that if you multiply it by itself, gets you 25. So we would say that the square root of 25 is 5. On the other hand, if you wanted to find, say, the cube root of 8, you need to find a number that if you multiply it by itself and then multiply it a third time by itself, you would get 8. So in this case, it would be 2. And if you wanted to do a fourth root, you would need to find a number times itself, times itself, times itself. So 4 times, a multiplication 4 times with the same number, that would give you 10,000. And if you can find such a number, because you aren't always going to be able to do that, you will have found the fourth root. Now, if it is an exact value, as it is here, you can use your calculator to find these. So for instance, if I wanted to do the square root of 36, now I happen to know the answer to that is 6, but if I wasn't 100% sure I wanted to check, you just do square root of 36, and there's your answer. It was 6. Now, if you wanted to find, say, the square root of 625, the answer would be 25. So if the answer is an exact value, you can do it. Now, square roots can also be written as fractional powers. So a square root is a half power. A cube root is a 1/3 power. And a fourth root is a 1/4 power, which allows us to use our calculator when it's an exact value again, at least, to do these examples. So for instance, if I wanted to do the square root of 36, it would be 36 to the power of, put a bracket around it and do 1/2. There's your answer. Now, if you want to find a cube root, you could go looking for cube roots in the calculator, but it's much easier just to do 64 to the power of 1/3. That's your answer. And you can check it. 4 times 4 times 4 is 64. I know it works. Now, if I want to find the fourth root of 81, 81 to the power of 1/4, and the answer to that one is 3. And you can check it, but 3 times 3 times 3 times 3 is equal to 81, and things work out quite well. So as long as this is a perfect value, right, a nice whole number, your calculator will get you the result. We'll look at later on, what do you do if it's not an exact value? Is there a way that you can simplify your radical? And you'll discover that there is. Now let's look at situations that don't have numbers. Suppose I wanted to find the square root of x to the power of 6. Well, I'm going to use the fact that square roots are the same thing as half powers. So it's x to the 6 raised to the half. And now there's a rule that says if you've got a power raised to another, you will multiply the two together. And the answer is x cubed. So if you wanted to find the square root of y to the 16, you'd call it y to the 16 raised to the power of a half. That would be 16 times a half. and that would be 8. And there's your answer. Again, in these questions, things are coming out quite nicely. Now, what happens if you, well, I don't know, stick a negative there? Well, the only effect that will have is that. So it's not a big deal. Now, suppose you have two variables inside the square root and you want to simplify. Then there's two steps. The first step is that you're allowed to separate square roots of two things multiplied into two single square roots. And then you can take each one of these in turn and simplify. Now, I'm going to do a shortcut. I know it's half that power, which means x. I know you could say x to the 1, but we just write x. I know it's half that power, which is 4. And so the answer is just x, y to the 4. Suppose you get the square root of a to the 10, b to the 8, c to the 12. Then you separate it as a to the 10, b to the 8, times c to the 12. Half that power, perfect match. Half that power, perfect match. Half that power. And then you can just write them together. Now, what happens if you mix and match? So I'm going to put a radical with numbers and powers in it. So suppose I wanted to simplify 25 x to the 4 y squared. Then you separate it as the square root of 25 times the square root of x to the 4 times the square root of y squared. This guy is 5. This guy is half its power. This guy is half its power. So your answer becomes that one. You finished. Now you can do the same thing with cube roots. Well, I'd separate that as the cube root of x to the 12 times, let's make it say 9, the cube root of y to the 9. And the only reason I'm putting brackets is just emphasis. Now, a cube root is a third of the thing, right? So square roots, you half it. Cube roots, you third it. So 12 into that gets you 4. And that guy, 9 divided by that, gets you 3. Oops. So your answer. Of course, you can also have numbers. So you can have the cube root of 8, x to the 6, y to the 12, z cubed. So that'll become cube root of 8 times the cube root of x to the 6 times the cube root of y to the 12 times the cube root of z cubed. And that's an exact value, which you can check on your calculator, is 2. Divide that by 3 and you get x squared. Divide that by 3, you get y to the 4. Divide that by 3, you get z. So your answer is 2x squared y to the 4 z. And we are finished. Now, what happens if you stick a negative in front of it? Just means the answer is negative. Negative in front of it just means the answer is negative. What adaptation do we do if it's the square root of 4 x to the 4 y to the 6 over, say, z squared? Well, you split it into square root of 4, square root of x to the 4, square root of y to the 6, all over square root of z squared. So you essentially, each piece gets treated separately. Well, that's a perfect number, that's 2. Perfect square, we call those. That guy is half the power. That guy is half the power. And that guy is half the power. And then you just call it 2x squared y to the 6 over z. Are we good? I hope so. So, moving on then, let's look at examples from, say, question 16. What happens if you get square root of a number and it's not an exact value? So I'd go to my calculator and I'd do, okay, square root of 96, and you get a horrible decimal. That means it's not an exact value, right? It's not a whole number. Things get a little bit trickier here, because what you need to do now is that you need to rewrite 96, and you need to rewrite it in a very, very specific way. You need to write it as two numbers multiplied together. One of them has to be a square number. I'll tell you in a moment what that looks like. And the other one is whatever's left, right? The rest. Square numbers are 4, 9, 16, 25, 36, 49, 64, 81, 100, and forever. And these are called square numbers. Now, square numbers have a nice property. They have exact values for their square root. So, for instance, the square root of that guy is 2. Square root of 25 is 5. Square root of 64 is 8. Square root of 100 is 10. So these are the numbers that you can choose from. So what you're going to have to do is find a square number times the rest, it's 96. But these numbers, the square number obviously has to be a whole number, but so does what's left. So essentially you're going to take 96 and you're going to check it against all these numbers. And it's always a good idea. You start at the biggest and work your way up until you get some number that divides 96 exactly. Now, if I look at this guy, it doesn't divide. Let's try 49 just as an experiment. So if I go 96 and I divide it by 49, doesn't work. Okay, so 25 is not a candidate. Let's try 16. So 96 divided by 16. And when I do that, I get the answer 6. So what that is telling me is that I can use 16 times 6. So the first step is that one. Find two numbers that multiply together that give you 96. One of them must be a square number, and the other one's what's left over. But whatever numbers you pick for your square number, the bit that's left over, this must also be a whole number. So it's not allowed to be 2.5 or 3.1234 or whatever. It must be a number like 5 or 6 or 8 or whatever it might be. Now, once you've done that part, you can then do the split me up part. That guy is 4. The other guy, you can't do anything to it. So this is considered the final answer. So the simplified version of the square root of 96 is 4 root 6. Let's do another one of those, 17. I want the square root of 147. And so I need to find some combination of that guy that's going to work. So let's look at things that multiply together that give me 147. And one of them has to be from this list. And again, start at the bottom and work your way up. And the minute you get one that works, you're done, right? Stop looking, you've found the right guy. If I try 64, it doesn't work. Let's try 49. That's got a possibility. 147 divided by 49 gives me 3. So I know that that one is the one I want. 49, it comes from here. 49 times 3 gives me that guy. I will then split it up as the square root of 49 times the square root of 3, and that gets me 7 root 3, and we are finished. Okay, try one more. Suppose I wanted to find the square root of 20. I want to simplify. Well, it's a pretty small number, so I really have to look at what my choices are, and they're very limited. 20 doesn't divide exactly into 16, and neither does 9 divide it. 4 does, and that one I can do in my head. That's 4 times 5. So it's going to be the square root of 4 times the square root of 5, and that gets me to square root of 5, and we are finished. Now, what about the same kind of question, but a cube root? So what we need to do that is a very similar process. We're going to do the cube numbers. So these are numbers that's cube root is a whole number. So the first one is 8. That's basically 2 cubed. Then you get 27. Then you get 64. Then you get 125, and then it goes on forever. A lot less to pick. I mean, it doesn't take long before these numbers get huge. So in the same way that we did this, I'm looking for 2 numbers that multiply together that give me 24. Both numbers have to be whole numbers, of course, right? And one of them has to come from here. Well, if I scan through that, it doesn't take long to realize it's 8, and 8 times 3 is 24. You can then split it into the cube root of 8 times the cube root of 3, and the cube root of 8 is 2, which you can check on your calculator, and you leave the other guy alone. And we have now simplified that guy. That's a version of question 19. It's a version of question 20 then. Suppose I wanted to find the cube root of 192. And I need to find a combination from this list. Right, now I'm looking through this list and there's not an awful lot of choices. 125 doesn't work. Right, next number might work. Let's try 64. 192, does it divide exactly by 64? And it does. So it's going to be 64 times 3. And that's going to break apart as the cube root of 64 times the cube root of 3. This is a nice number, happens to be 4. Cube root of 3, we are finished. And there is your answer. So what we're now going to do, kind of the last part, is we're going to look at how to simplify radicals where the numbers don't work exactly. We've seen that, but neither do the powers. So suppose I asked you to simplify that one. Well, you would basically, if you're doing it the long way, would say, oh, 6 times a half. You would say x cubed. But after a while, don't you just say if you half the power, you'll get the answer, right? Square roots for half powers. But what happens when you get something that's not quite a half, right? It doesn't, get divided by 2 easily. If I wrote that down as 7 halves, that wouldn't really be very helpful. If I called it 3.5, which it is, that might be a little bit more helpful. But you can see it's quite difficult to do. So what you do, well, this is one way to do it at least, is take 7 and then in your mind, divide it by 2. Now that gets you 2 things. It gets you 3 and then 1 left over, which we typically call a remainder. So 3, remainder 1. The 3 gives me x cubed, and the remainder of 1 gives me 1 square root. So that's how I would do this question. It would be x cubed, square root x. Let's try one. X to the 13. Right, if you divide that by 2, you get 6.5. So you get x to the 6 and 1/2 left over. If you want x to the 21, if you divide it by 2, you get 10 and 1 left over. If you take 5, divide it by 2, it goes in twice and 1 left over. Do you see how it works? 1 left over, 1 left over, 1 left over. So let's put a number of variables together inside the square root. And we have an x cubed, a y to the 4, and a z to the 7. This is similar to question 22. Now it's going to split then as an x cubed times a y to the 4 times a z to the 7. Each one of them is going to get treated on its own. So let's do the middle one. Half of that guy is a perfect match, y squared. Now, if you divide this guy by 2, you get 1 and 1 left over. If you divide z to the 7, right, if you divide the 7 by 2, you get 3 and 1 left over. And then you tidy up. So you get x, y squared, z cubed, followed by a square root of x and a square root of z. And then we tidy it up even more by only having one square root. And that would be our final answer. Now you're going to make it more difficult, like in question 23. You add one extra layer, you add a number. Right, that guy. That's going to be the square root of 8, the square root of a cubed, and the square root b to the 8. If you take half that power, you get a perfect match, b to the 4. If you take half of a cubed, you get 1.5, you get 1 and 1 left over. Now the square root of 8, you would have to do using, this trick here, but eventually what you get out of that is 4 times 2, which gets you 2 square root of 2. Right, so that guy eventually will simplify as 4 times 2, which gets you 2 root 2. You then tidy everybody up by putting a 2, an a, and a b to the 4, a square root of 2, and a square root of a, and the square roots get put together like that, and there is our answer. So let's do a version of, say, 25. Square root of 28 x y to the 9 z to the 14. That's going to split as a square root of 28, a square root of x, a square root of y to the 9, and lastly z to the 14. Okay, I'm going to start at the end because I want to. Square root of z to the 4, half that power, perfect match, 9. This one. If you take 9 and half it, you get 4 and 1 left over. So you get y to the 4 and 1 left over. Gives you that guy. Now the square root of x is a little bit of a trick. There's nothing you can do to simplify it. So I'm just going to rewrite it. The square root of x. And then you're going to have to do this guy. And if you do it, it's 4 times 7, which then simplifies down to 2 root 7. Now you combine everybody, you get 2, a y to the 4, a z to the 9, with a square root of 7, with a square root of x, with a square root of y. If you combine all of the square roots together, you get the square root of 7, an x, and a y. There is our answer. Now, in the same way that we simplified square roots, we're now going to simplify cube roots. Well, if I find the cube root of y to the 12, basically you just divide it by 3 and you get y to the 4. That's a nice match. But what happens if you have to find the square root of something that doesn't match? Now, if you do this as a division, you'll get 3 remainder 1. So this is y cubed, and the remainder of 1 gets you that guy. Now, if you want to do a cube root of x, say to the 13, 3 goes into 13 4 times, and 1 left over. If you want to do cube root of b to 22, 3 goes into 22 7 times, and 1 left over. Now you could, when it's a cube root, you wouldn't get this in a square root, but you could in a cube root have 2 left over, right? So for instance, if you want to do the cube root of y to the 11, it goes in 3 times and 2 left over. 2 left over gets you y squared. If you want to see where that comes from, it's essentially 11 thirds, which gets you 3 and 2 thirds, which gets you a y cubed and a y to the 2 thirds. Now, when you have a fractional power like 2 thirds, the denominator tells you it's a cube root, and the numerator tells you it's y squared. So that's essentially why that, or where that came from. Okay, let's put that package together and finish off with a couple more examples. Here's the version of 27. It's going to be the cube root of a to the 14, b to the 17, and c to the 18. So I know that's going to split a to the 14, b to the 17, and the cube root of c to the 18. Okay, let's do this one first. If you do 14 and divide it by 3, you get 4 and 2 left over. 4 and 2 left over. Now, if you do 17 divided by 3, you get 5 and 2 left over. 5 and 2 left over. And if you do 3 into that, you get an exact match of 6 and nothing left over. Now you combine them, you get this fella, you get this fella, you get this one, a cube root of a squared, and a cube root of b squared. We combine the cube roots, we're allowed to do that. And we get a single cube root of a squared b squared. Okay, my last question. Something like 28. Cube root again. A to the 5, b to the 14. It's going to be a cube root of a to the 5 times a cube root of b to the 14. 5 divided by 3 gets you 1 and 2 left over. 14 divided by 3 goes 4 times and 2 left over. I have an a, b to the 4, cube root of a squared, cube root of b squared. And now we combine them into a single cube root. And we're finished. And that is this topic. So hopefully that is enough help to get you through the first homework from assignment 5.